Good morning. Topic for this video is about Weirs. Okay? Itong topic na Weirs ay madali lang kasi literal na parang direct substitution lang din sa mga formulas yung problem solving. Pero syempre, bago natin um, bago tayo mag-solve ng problem sa Weirs, alamin muna natin kung ano mismo yung Weirs. Okay? Napakita ko na sa inyo yung video last week kung ano yung ginagawa ng Weirs, pero let's discuss again kung paano siya gumagana o bakit ito mahalaga. So, ito yung definition ng Weir. So, this is a low-head dam that is a barrier across the width of a river that alters the flow characteristics of water and usually results in a change in the height of the river level. They are also used to control the flow of water for outlets of lakes, ponds, and reservoirs. Okay, so ganito. Siyempre, gawa natin ng drawing. So, ito yung mga formula. Mamaya, i-discuss natin yan sa isa. So, halimbawa, meron ka rito isang malaking dam. Okay? So, let's say this is a dam. Tapos, syempre, diba yung mga dam, meron niyang mga gates sa dulo. Okay? Those gates are used to release water. Kung kailangan maglabas ng tubig, edi bubuksan yung gates. Okay? So, yung gates na yan, syempre, hindi naman basta-basta bubuksan yan at pakakawalan nila kung saan yung tubig. Okay? Syempre, controlled pa rin ang flow dyan. So, yung gates na yan, meron niyang mga channels. Yung channels ay daloy ng tubig which is open to atmosphere. Kasi meron tayong dalawang types generally meron tayong dalawang types ng conduits kung saan nagpo-flow yung tubig. Unang-una, meron tayong closed conduit. Okay? Meron tayong closed conduit o commonly, these are pipes. Okay? Sinabi mo closed conduits, they are these conduits na hindi subjected to atmospheric pressure. Ibig sabihin, the pressure gauge inside is not zero. Okay? The pressure gauge in the flow or the pressure head in the flow is not zero. Okay? That is a closed conduit. Tapos, meron tayong open. Okay? Meron tayong open conduits. Okay, let's say these are the open conduits. Okay, and they are open to atmosphere. Kapag ka-open to atmosphere, alam natin na gauge pressure doon sa flow is equal to 0. Okay? So, siguro may mga dams na gumagamit ng pipes, may mga times na gumagamit ng gates, ng channels. So, let's assume na itong spillway na to ng dam is a channel. Okay? Ngayon, pagka nagbukas ka ng gate, okay? Pagka ikaw ay nagbukas ng gate, hindi mo controlled yung tubig na lumalabas dyan. Basta na lang bigla umaagos yung tubig na nandiyan. Okay? Ngayon, to better control the flow of water na lumalabas doon sa dam, ganito ang gagawin natin. To better measure the discharge na ginagawa ng dam para mas makontrol natin, para alam natin, para hindi tayo basta pakawala ng tubig. Para alam natin kung ano yung nangyayari o kung gaano karaming tubig na nilalabas ng dam per unit of time. Naglalagay tayo ng weirs o ng mga harang dyan sa daan. Okay? So, naglalagay tayo ng mga harang dyan. Ano yun? I-spot detail natin to. Okay? So, kung ito yung channel, syempre that is open to atmosphere. Oops. Say, that's your channel. Okay. Yan, bukas to. Syempre, open to. Tapos, may water flow dyan. May water flow dito. Ito, nilipis ng pens ko. Wait lang. Nilipis. Okay. So, dyan, merong incoming tubig. Okay? So, ang gagawin dyan ng weir, anong mangyayari kapag may weir dito? Let's say may weir na ganito kataas. May weir kunyari na ganyan kataas. Let's say this is weir. Okay? Pag sinabi mong weir, literal na harang yan. Harang yan sa daan ng tubig. Okay? Ayun, sabi, a barrier. Okay? A low head dam. Pag sinabi mong dam, it holds water. Okay? A low head dam, mababang dam. Actually, hindi dam o barrier. Let's say barrier na lang. Okay, so yan. Siyempre, kapag may harang dyan sa daan ng tubig, siyempre, the flow of water will rise. Tama? Kasi siyempre, maghahanap ng labasan yung tubig. So, kung let's say, nung walang harang, ang flow ng tubig doon sa channel ay ganito lang kababa, siyempre, hindi siya makakalagpas dito sa may gate. Pero siyempre, since the discharge is continuous, it will eventually go up. Okay, aakyat yan doon sa may level nung Weir, okay? Hanggang sa ma-overcome niya yung height ng Weir. Okay, syempre kapag na-overcome niya na yung height ng Weir, syempre na-back up, naharangan yung tubig doon sa likod, it backs up. Tapos dahil doon sa harang na Weir, tumaas unti-unti yung water level hanggang sa ma-overcome niya yung height ng Weir. Syempre tatapon na siya diyan sa may labas. Ngayon, sir, teka, hindi ko magets kung paano na-control yung discharge nun. Ay, paano na-control yung discharge? Kasi ganun din naman yun, sir. Siyempre, maglagay ka mo lang dyan ng gate o hindi, yung discharge ng dam is tuloy-tuloy. Oo nga, pero this weir is a means of measurement. Okay? A means of measurement kung gaano karaming tubig na lumalabas doon sa dam. Okay? Kasi, pagka meron tayong weir, kadalasan, sinusukat na lang natin yung taas ng water level from the weir. Okay? Gaano kataas yan? Gaano kataas yung lampas ng tubig mula dun sa may pinakataas top of weir. Okay? And as long as we have this head of water above the weir, okay, alam natin kung ano yung discharge. Okay? Kaya kung makikita nyo rito, Q is discharge. Okay? This is our way of measuring discharge over weirs, okay, over several shapes of weirs. Kung mapapansin nyo, lahat sila merong variable na h. Okay? Kasi, tawag dyan, kasi the discharge over a weir is measured in terms of head of water h or in terms of kung gaano kataas yung tubig level mula doon sa may taas ng weir, mula rito sa may top of the weir. Okay, gets? So yun, ganun lang kadali. Susukatin lang natin kung gaano kataas na yung water level over the weir, then alam na natin kaagad kung ano yung discharge ng tubig that is going out of the dam. Okay? So yun ang gamit ng weir para masukat natin kung gaano kalakas, kung gaano kabilis ang release ng tubig dun sa dam. Okay, although, kung maisip nyo, hindi kung wala namang weir, kung walang weir, edi, pwede ba natin siya sukatin with other means? Oo, pwede. Pero, it is better controlled with weirs. Okay? Kadalasan nga, hindi lang isang weir ang naandyan. Okay? Kadalasan, that's a series of weirs to better control the flow of water. Okay? Nakakita na kami ng actual neto doon sa field trip. Siyempre, pumunta kami ng dam. Then, makikita nyo yung channels pababa. May mga dams talaga. May mga channels talaga. Tapos may mga weirs. Parang, I think, yung nakita namin na actual is ganito. Actually, yung channel niya is trapezoidal. Trapezoidal yung channel niya. Oops, pangit drawing. Iyan. Trapezoidal channel, then, ang weir niya is like contracted rectangular, parang ganito. Ganyan ang weir niya. Tapos, it's a series of weirs. I think tatlo. Sa isang channel, may tatlong ganyan na weirs. Okay, that's to better control the flow. Okay, so yun. That's the use of weir. So for this lesson, ang pag-aaralan natin is kung paano lang mag-compute ng discharge over a weir. Okay? If the water level is this high, gano'ng kalakas na yung discharge no? Kasi gano'n naman lagi. Makita lang natin kung gaano kataas yung tubig level from the lip of the weir. Solve ka na. Okay, so this is like a direct substitution na lesson dahil yung mga formulas dito is empirical. Okay? Tandaan mo na sa engineering, we have two types of formulas which are the first type of formula is rational And the next type is empirical. When you say rational, ito yung mga formulas na may derivation, merong explanation bago biglang lumabas. Like, strain or stress is proportional to strain, parang ganyan. Or the other formulas of mathematics, kadalasan dun mga rational formulas. Empirical formulas, these are formulas na hindi mo madederive at isa pa, hindi mo madedescribe yung unit. Okay? I mean, hindi mo may explain kung bakit lumabas yung ganung unit out of this formula. Katulad nito, sa formulang to. This is called Francis formula, and this is for rectangular weirs. When you use length, ang unit niyan is of course meter o feet. Okay? Meter or feet. Tapos, yung height, ano yung height raised to 3 halves? That's m raised to 3 halves. Kapag kung titignan mo yan, ang unit niyan is, ang unit dapat na sagot mo is meter raised to 5 halves, di ba? Hindi meter squared, hindi cubic meter, kundi meter raised to 5 halves. And it doesn't make sense. Let's say, ganun. Okay, pero ang unit ng discharge is, of course, cubic meters per second. Tama? Kapag feet, that's cubic feet per second. At hindi mo siya makakapa doon sa formula. Okay? Pwedeng na andito siya, nakahalo doon sa may numerical coefficient, pero you can't really say. Okay? So, yun. Dito try natin kung ano unit na ito. Pagka may square root of 2g. Diba? Pag g, that's meters per second. Meters squared per second. Anong square root ng meter squared per second? And they beat meter per square root of second. Pag minultiply mo sa meter raised to 5 halves dahil may LH raised to 3 halves sa dulo, eh mukhang wala pa rin. Kaya hindi pa nalalabas sa cubic meters per second. Okay? So, yun. That's why these are empirical formulas. We cannot really derive kung saan sila nanggaling. Actually, they are from repetitive studies. And dahil sa repetitive studies na yun, nakapag-develop sila ng formula. Okay? So, yun. So, let's start. So, types of weirs, we have rectangular, suppressed, sharp-crested, broad-crested, contracted. Ito lahat rectangle to. Okay? Kasi syempre classified yung weirs natin in terms of shape. Okay? Actually, ito yung type, number 1, number 2, and number 3. These are types of weirs according to their shape. Okay? Marami lang sub-categories sa rectangular. Suppressed, sharp-crested, broad-crested, and contracted. Okay? Next is triangular. Of course, triangle na weir, then trapezoidal na weir. Yung submerged, this can be any other weir. It can be rectangle, it can be triangular, it can be trapezoidal. Submerged is more like a condition of a weir. Okay? Paano kapag yung weir is lub-lub na? Lunod na yung weir. Ano na yung discharge niya? Yun yung submerged weir. Okay? May mga example tayo niyan. Lahat yan, we have 7 examples. So, pressure, crested, so 4 dito, then 1, 2, 3. We have all 7 examples. Okay, so let's start. O nga pala, bago natin, kalakihan nga natin to, I think, masyadong maliit. Lalo kapag sa cellphone ka lang, o sa cellphone ka nanonood. Wait. Yan. Take ko, okay niya. Okay, so, we have this, Francis, we have this rectangular weir. When you say L, kaya ano yung length ng weir? Yung length ng weir is actually the, wait. Diba, ito yung, actually that's the length kung saan nag-overflow yung water. So, kung halimbawa dito, wait, example natin dito, okay, ito yung length ng weir, okay, ito, yan. That's the length of your weir, okay. Kung halimbawa naman dito, syempre kapag ka umagos yung tubig dyan, so dito yung lalabas, okay. So, the length of weir is only ito. The length of rectangular weir. Okay? Basta yung length nung parang pinaka-lip ng weir, where water overflows. Ito. L. That's the length of weir. Okay, so Hala. Yan. Ayan. So, yun yung length ng weir natin. Then, itong C, constant C, when rectangular weir, pag sinabi use Francis formula, it means use 1.84 LH raised to 3 amps. Ganun lang kadali. Wala nang computation ng constant C. Okay? Pero if the type of crest is specified, when you say crest, yung pinakalabi ng weir. Okay? We have sharp crested, we have broad crested. So kung isa-side view natin yung weir, let's say ito yung channel, okay, daanan ng tubig. Kung yung weir mo ay ganito ang itsura, diba, ito yung weir, that's just a vertical structure o vertical na nakaharang. Tapos matalas yung kanyang pinakalip. Okay? Ano to, cross section. Sorry, ano pala, profile view o side view. Okay? Ito yung tubig. Ayan. If this crest is specified to be sharp, ang gagamitin mo is itong formula na to. Okay? Pero pag sinabi sharp crested, pero still use Francis formula, di wala problema. Still use Francis formula. Okay? Pag sinabi naman broad crested, edi ano siya, ganito. Wait. Hindi siya matalim. Kasi mahaba, broad. Okay, malapad yung weir mo. Kasi mga ganyan. Yan. Pero pag tinignan mo siya sa front view, either sharp or broad, pagka naka-front view tayo, ito yung channel. Okay? Ang itsura niya ay ganito pa rin, rectangle pa rin. Okay? So, yun. Unang-unang type is suppressed rectangular weir. Pag suppressed rectangular weir, sabi ko nga, pag suppressed rectangular weir, this could be sharp or broad crested, pero this is like a general rectangular weir. Pag sinabi mong suppressed, it extends from one side of the weir hanggang dun sa dulo. Yun lang. Yeah. Yan lang, ibig sabihin niya. Pag naka-front view ka, sagad, from dulo to dulo, merong harang dun sa flow. That is suppressed weir. Okay? Yan, that suppressed weir could be sharp or could be broad-crested. Pag in-specify, gamit ka rin sa mga formula na to. Pagka in-specify, pagka suppressed weir ang problem, Francis formula matic. Okay, pagka suppressed rectangular weir. Okay, so yun. Ano naman yung ibig sabihin ng contracted weir? Pagka contracted weir, ganito. Let's say this is the front view. Sorry. Bago yan, discuss muna natin to. So, sa suppressed weir, stain ko, wala tayong problema. Ulit ha. Ganito. Pagka suppressed weir, di ba ito, the water is overflowing dun sa taas ng weir. And ito yung, pagka front view mo, ito yung front view. Okay, this is tubig. Nalalaglag yan. Paharap ng weir to. Ito side view, tapos ito front view. So, yung tubig, umaapaw dun sa weir. Ang H mo ay ito. Tulad ng sinabi ko kanina. From top of water hanggang dun sa may pinaka-crest ng weir. Okay, this is head of water. Okay? And this is length of weir. I-discuss ko na kanina. So, yun. Wala ka ng problema dito. That's just a direct substitution. Ito naman, sa sharp-crested weir, so you know the definition of length and height o head of water. Ito ang square root of 2G. G is just 9.81 for SI and 32.2 for English. Yung C naman is kino-compute pa. Bukod pa ang formula ng C. Okay? So, ayan. C is 0.611 plus 0.075H. H is the same H, yung head ng water. Okay? So, na-define na natin. And P is the height of the weir. Okay? So, ito yun. From the bottom of the channel hanggang dun sa may crest, that is P. Okay? It is better to define muna yung formula bago tayo mag-atake sa mga solving. Okay? So, ganun lang. That's still direct substitution. Okay? Pag sinabing rectangular weir at walang binigay na C or constant, okay, at walang sinabi sa problem, automatic Francis formula ang gagamitin mo. Or commonly, binabanggit sa problem na use Francis formula for solving. Now, if the weir is rectangular suppressed weir, pero binigyan ka ng letter C o constant, weir constant, etong C na to. Okay? So, ang mangyayari dyan, ang gagamitin mo is itong formula na to. 2/3 C squared of 2G LH raised to 3/2. Kasi actually, pagka rectangular weir, ito talaga yung pinaka-general na formula. itong 2/3 C squared root of 2G. Kaya nga itong formula na to ay same din sa broad crested. Ang magbabago lang is yung C. Kasi nga they are both rectangular. Okay? Pero special formula, o ibig sabihin, easier formula for rectangular weir is Francis formula. This is simpler. Okay? So, yun. Pagka ayaw natin kumpitin yung C, the Francis formula, ginagamit natin. Pagka broad crested, ganun din. H and P, dinefine na natin yan. Okay? So, doon tayo sa contracted weir naman. Dinedefine muna natin bago tayo mag-solve. Sa contracted weir, sandali lang. Okay, let's assume. So, doon tayo sa contracted weir. Siyempre, contracted weir is still rectangle. Okay, subtopic nga natin eh. So, siyempre, may nakaharang pa rin na rectangular weir doon sa daan. Okay? Pero unlike the regular suppressed rectangular weir na it only extends from side to side, yung contracted weir, hindi po nakontento kasi meron pa siyang palikpik doon sa gilid. Okay? Kasi ito, hinahayaan niya lang mag-overflow yung tubig sa taas niya. Si contracted weir, meron pa siyang palikpik sa side. Yan. This is a one-side rectangular weir. Okay? And may factor yan. Okay? Ito syempre the water flows occupies the whole area of the channel or the whole width of the channel. Pero pagdating doon sa weir, so syempre medyo napipigilan pa yung pag-agos niya dahil may contraction from one side. Ibig sabihin ng contracted, syempre parang mas pinakipot yung daan. That is contracted weir. Okay? Pagka one side rectangular weir, pagka one-side rectangular weir, ang length natin, actually ang formula is ganun din. Kung use Francis formula, di ito, okay, ang gagamitin, 1.84. If bigyan ka ng C, di ito ang gagamitin mo, yung formula na 2/3 something. Okay, so, pero yung L na ginagamit natin sa contracted weir is modified. Okay? And sabi nga dito, that's L prime. Okay? Paano kino-compute yung L prime? L prime depends kung yung contraction ba is nasa isang side lang or nasa dalawang side. L prime is equal to L minus 0.2H. Ano yung definition natin ng L kanina? L is the width of the crest where the water overflows. Okay? So kung ito lang yung daan ng tubig, this is your L. L lang hindi L prime. L lang yan. That's L. Okay? Now, that L is further reduced. Okay, dahil dun sa contraction. So, L minus 0.2H. And yung H, hindi ganun din. If this is the water level na nag-overflow above the weir, then this is H. Okay? If that's a one-side contraction, edi ang length L prime mo is L minus 0.1H kasi one contraction lang. If the contraction is dalawang side, drawing tayo ng two-side contraction. Two-side contraction, ganito. Yan. Okay. Tapos, water level is yan. So, ang L natin is this. And syempre, hindi pa yun yung gagamitin mo. Kasi yung gagamitin mo sa Francis formula is L prime. Okay? That's L minus 0.2H kasi dalawa yung contraction. Okay? So, madali lang tandaan. Okay? So, in short, yung example kong rectangular weir kanina, ito, this is a contracted weir. Kasi meron siyang harang din dun sa gilid. Okay? So, yun. I think pwede na tayo mag-example sa rectangular weir. Okay? O siguro discuss pa rin natin yung kasunod. May na. Rectangular weirs muna tayo. Okay, so example number 1. So a flow of 10.9 cubic meters per second passes over a suppressed weir, which is 4.88 meters long. So the total depth upstream from the weir must not exceed 2.44 meters. So use C equals 0.63. Okay? So Question number 1 is compute the velocity of approach o kung gaano kabilis yung tubig before it hits the weir. Okay? Then next is compute the head of the weir. Gaano kataas yung tubig, yung tubig over the crest, and determine the height to which the crest should be placed to carry this flow. Okay? So ito yung problem sa OneNote. O nga pala, reminder na minsan kasi ganito. Ang general formula kasi ng weir sa kahit anong weir ay C times L times H raised to N. Okay? So, ito yung general formula. Ito yung pinaka-general formula sa pagsusolve ng discharge weir. Okay? Itong length is yung property niya ng weir. Itong height is kung gaano nakataas yung tubig dun sa ibabaw ng lip ng weir. Itong N at saka itong C ay these are weir constants. Okay? These are weir constants. So, nakadepende to kung anong shape ng weir. Okay? If the weir is rectangular, N is 3/2 or 1.5. If the weir is triangular, ito yung mga common na shape N is 5/2 or 2.5. Okay? So, ganun. Itong C, nakadepende rin sa type ng weir. Ganito, kapag binigyan kayo, sa rectangular weir, kapag binigyan kayo ng C na malapit na sa, let's say, 1.84, dito sa 1.84, use that whole C instead. I-substitute mo na yun dito sa buong to. Ay sa buong C na to. Itong buo na coefficient, LH type halves. Okay? Pero if that C is less than this value, let's say nasa mga 0.8 or 0.7, 0.6, then use that C to substitute dito sa letter C na to. Okay? Ngayon, since our given C is only 0.63, okay? Dito natin siya gagamitin lang. I-substitute lang natin siya dito. So may 2/3 C squared of 2G. Substitute natin siya dito. Diyan sa C na yan. Okay, pero if the given C is 1.85, 1.84, 1.83, substitute that value to the whole factor na ito. Palitan mo na itong 2/3 C squared root of 2G. Okay, kasi sa iba-ibang books, iba-iba ang pagkaka-interpret ng C. Okay, merong C na dito lang sa formula na to, or merong C na sinasubstitute na niya yung buong value nito. Okay? Kaya na this is 1.85. Pinalitan ko, ginawa ko muna ng 0.63 kasi it will cause confusion kung this is 1.85. Tapos, ang gagamit nating formula is 1.85 LH 3/2. Okay? Kaya sabi ko nga, yung C, pinalitan natin. Dahil yung C malapit na sa 1.84, pinalitan na natin yung C ng 1.85. As in, sinubstitute na natin yung itong 1.85 na to, siya na yung tumayo sa value ng 2/3 C square root of 2G. Okay, now if that C is mababa, tulad nito, 0.63, then substitute that C dito sa C na to. Kailangan po siya i-multiply sa 2/3 square root of 2G. Okay, so yun yung gagawin natin yan. I hope that makes sense. Okay, dito sa problem natin, nasabi, ang discharge doon sa channel is 10.9. Okay, ang discharge na umaagos doon sa channel is 10.9 cubic meters per second. Okay, tapos the weir is suppressed. Ibig sabihin, it extends from one end to one end. Okay, rectangular. And the length of weir is 4.88 meters long. So, ibig sabihin, kung yung front view natin siya, or kung gagawin natin yung view, ang length is 4.88. Okay. So, the total depth of upstream from the weir must not exceed 2.44 meters. Ang sabi, etong lalim na to from the channel bed ay should not be greater than 2.44. So, may limit dyan. Okay? Ano, total depth upstream. Ibig sabihin, the depth of water behind the weir. Okay? So, from the weir must not exceed 2.44. Then use C, okay? 0.63. Ito yung mga question. Velocity of approach. Alam natin na the channel is rectangle. And alam natin yung discharge formula as area times velocity. Okay? If ito yung cross-section, wait, if yan yung cross-section, okay, and we know na ang length niyan ay 4.88 and alam natin na ang height ng tubig is 2.44 meters, then the area ng tubig, area of a cross-section ng tubig behind the weir is 2.44 times 4.88. So we have this area. Okay? Then we also have the discharge na 10.9. So malalaman natin kung gaano kabilis yung velocity ng tubig dun sa likod ng weir. Okay? So, yun. So, kung kukumpitin natin yung discharge o yung velocity, velocity of approach, so 10.9 cubic meters per second. Teka, laki natin sulat. Feeling ko maliit yan eh. 10.9. Hindi ko na nilagay unit. Equals area 2.44 times 4.88 times V. Okay, so the velocity of approach or the velocity of water doon sa channel is, so that's 10.9 divided by 2.44, times 4.88. So that is 0.915. 0.915 meters per second. Okay, so that's velocity of approach. Next is the head of the weir, o kung gaano kataas yung tubig doon sa weir. Ngayon, the problem is, kung alam natin yung 2.44 at alam mo itong letter P na to o yung height of weir above the channel bed, alam mo na kagad yung head of weir. Pero walang binigay na height ng ng weir. So, makumpitin muna natin itong H. Okay, so ang sabi natin, for discharge sa rectangular weir, that's 2/3 C square root of 2G times L H raised to 3 halves. Then ang sabi natin, if the value of given C is mababa, 0.6, 0.7 something, then we use that value to substitute for this letter C. However, if the given C is higher, like 1.85, 1.83, nasa ganung range, then use that value to replace this whole factor. Okay? So, depende sa given. Kasi depende sa pagkaka-interpret ng libro. So, yun. Equals, since mababa yung given, substitute natin dito. 2/3 times 0.63 square root of 2G. Hindi ko na nalagay unit since this is empirical, and we expect the unit to be in cubic meters per second for discharge. Length is 4.88 and head is unknown. Raised to 3 halves. So kung papansin nyo, this is basically shape solve lang, direct substitution. Okay? So let's solve for H. So 10.9 equals 2/3 0.63 square root of 2 times 9.81 4.88 x raised to 3 halves or x raised to 1.5. So ship solve, then the height of water above the crest should be, wait, excuse me, Processing. Ayan, 1.1296. 1296. Okay? Meters. So if this is 1.1296 and this is 2.44, then alam na natin kung gaano kataas dapat yung crest. Okay? Alam natin kung gaano kataas dapat, gaano katangkad yung weir. And yung last question, ano yung height to which the crest should be placed to carry this flow? Okay, so parang planado na lahat mula sa simula. We know the discharge. Okay? We know the limit of the height dun sa channel. So, ang in-adjust natin is yung weir na lang. Yung height ng weir. So, this P is equal to 2.44 minus 1.1296. So that height of weir equals 1.3104 meters. Okay, so that's your answer. Ito yung mga sagot na hinihingi sa atin. Velocity of approach, the height of the head of water above the crest, and the height of crest. Okay? Ngayon, pwede makita nyo itong problem na ito sa pinagkuhanan ko. Pero the given and the solution ay iba. Kasi doon, kinonsider yung velocity of approach. Kasi considering velocity of approach, meron pa tayong ibang formula for discharge. Okay? Kung ibigay yun ng konting discrepancy, but to make the discussion simpler, hindi ko na yun isasama. Okay? So we are just focusing on the general formula of the rectangular weir na 2/3 C squared of 2G and the Francis formula. Okay? If you use Francis formula here in this problem, malapit lang din yung sagot. Ay may mga konting discrepancies lang. Okay? So we are not going into that very deep detail. Dito na lang tayo sa medyo generic. Okay? Next topic is ito. Actually, ito rin yan, pero pakita natin sa presentation. So, ang sabi is, a sharp crested weir, so specified sharp crested, horizontal channel is 10 meters wide. So, alam niyo na ibig sabihin nun. And 1.4 meters high. Itong wide na to nag-refer siya sa, actually, sa formula nag-refer siya sa length ng weir. Okay? And 1.4 meters high, so binigay. If the upstream depth is 3 meters, so we already know the head of water above the crest of the weir. Ang sabi, compute the discharge coefficient CW for a sharp crested weir. So, most probably, ang pinapakompute niya is ito. Wait. Ito. Yeah. Itong C na to. 0.611 plus 0.075H. Okay? Yung C na pinapakompute. And next question is compute the value of weir factor C. Okay? So, iba yung, ang tawag niya dun sa letter C, di ba, ang discharge formula is C, Q equals, ano yan? Ang general formula is C raised to L H N, okay, for all types of weirs. Ngayon, for rectangular weirs, ang formula is 2/3 C raised to square root of times square root of 2G L H raised to 3/2. So, kung mapapansin nyo, considering this general formula for rectangular weir, yung C na to, yung coefficient, is ito. Pinalitan na ito. Okay? And within that C is meron pang mas maliit na C. Depende kung anong type ng rectangular weir yung ginamit mo. Sharp, broad, etc. Okay? And N is raised to 3/2. Okay? Dun sa unang tanong, so para mas malinawan yung mga nagsosolve, kung ano yung pinapasolve niya, ginawa niyang C sub W ito. Okay? And the discharge coefficient C sub W for a sharp crested weir. Yung susunod na tanong, pinapakompute niya is the value of weir factor C if the formula is eto, which is eto. So, ang pinapakompute niya sa letter B is eto, which is Eto lang, napakadali. That's just direct substitution. Okay? And we can guess that it's around 1.8 something or 2. Mga ganun. Next is compute the discharge of a sharp crested weir. So, wala na. Direct substitution na lang dito. Napakadali. Diba? Kailangan mo lang i-interpret kung ano yung sinasabi at yung pinapakompute. Kaya ako iniba yung C dito dun sa unang problem Kasi this is our first example and nakakalito kung iba-ibang C ang gagamitin natin. Kasi itong C na binigay sa problem, it is not clear kung ang binigay niya ba is ito ba? C ng weir o yung C ng discharge coefficient. So, it's not clear. So, para mas mali, para mas hindi nakakalito, ginawa ko na lang yung C na kung ano yung nakikita nyo sa formula. Pero sabi ko nga, you can have a good guess. Depende sa given value. If that's this small, and probably that's itong C na to. Okay? If that is 1.8 pataas, probably that's the whole C for the formula. Okay? So, let's just direct substitute. So, para dun sa C for a sharp crested weir, that's 0.611 plus 0.075 H over P. So, hindi ko na substitute yung mga values. Let's just substitute sa calculator. So, 0.611 plus 0.075. Ang H natin as given is 1.6. And P is 1.4. So, C is at 0.6967. So, yung value na yan, so dito lang yung mabagsak kasi sub W. Maliit lang yun Okay, let's just store this. 0.6967. Okay. Next question. Let's say this is just C sub W. Then C for the discharge coefficient. So, C is that 2/3 C, which is stored sa A, square root of 2G. Okay, then that is 2.0574. Okay, so kung ganyan yung mga value ng C, 1.8, 1.85, 2, so that is the whole C for the formula. And for the discharge, edi gamitin mo na lang yung formula na since ito na-compute natin to, di ba? So the discharge is just 2.0574 times length na 10 meters daw. Tapos head is 1.6 as shown doon sa figure. Raised to 3 halves. Direct substitution, nakakainit i-solve. So yan. Times 10 times 1.6 raised to 3 halves. Okay. So that's 41.64 cubic meters per second. Okay. So that's it for that problem. Number 3 is broad crested. Ang naibala naman sa broad crested is yung formula ng C. Ito lang. 0.65 over 1 plus H over 3 times raised to 0.5. Anyway, let's proceed. So a broad crested weir in a horizontal channel is 10 meters wide and 1.4 meters high. So if the upstream depth is 3 meters, and okay, binigay ulit yung upstream depth. Compute the discharge coefficient for C sub W. So that's easy. Katulad nung sunod natin kanina. The wear factor and the discharge. Ang dali lang din. Parang ganun lang din. So let's just solve. Patulan na natin tong problem na to. C is, ano yun? Limutan ko tuloy yung formula. Ito. Ayan, 0.65. Isip ko yung number. 0.65 over 1 plus H over P raised to 0.5. Dahil magkaiba ang characteristics ng broad and sharp crested, syempre may pagkakaiba ng konti sa value ng discharge. Okay, so 1 plus, ang head natin this time is, kung 3 meters ang taas ng tubig upstream, and the, ano yan? and 10 meters wide, 1.4 meters high. Okay, ito 1.4 itong P. So 1.6 din ang head. Okay? Then P is 1.4 raised to 0.5. So C is 0.44. So makita nyo, mas maliit yung C. Then the C, let's say this is just C sub W. Then the C for the whole formula, ito, full value of Weir factor C, that's just 2/3 times C, or times C sub W, times square root of 2G. This is the general formula of C for rectangular Weirs. That's just 1.311. Okay? And for the discharge, edi ano lang, CLH raised to 3/2 because that is rectangular Weir. So, 10 meters din naman daw yung width o yung length kung ibabasa natin sa formula. So, answer times length na 10 times h is 1.6 o yung head of water raised to 3/2. So, that's 26.54 cubic meters per second. Okay? So, ganun lang. Kadali. Next is the rectangular contracted Weir. Okay. So, next is rectangular contracted Weir. Sabi, after heavy downpour, the depth of water of the Weir was 4 meters. Total discharge to the Weir was 1 million cubic meters. How long did the flow over the Weir last? Okay? So, this is a different situation kasi yung, sabi, umulan, so binaha, yung channel siguro, binaha, o yung kanal, o kung ano man yun. Tapos, nagkaroon ng 1 cubic meter discharge over the Weir. Okay? Pero the difference is, hindi constant yung head dito. Sabi, nagsimula ng 4 meters yung Weir, yung head, tapos syempre naubos yung tubig kasi nga variable head, tapos hanggang sa naging 0 yung discharge. Ang tinatanong, gano'ng katagal yun nangyari? Okay? Ang sabi, if the contracted Weir uses a length of 200 meters, and ang sabi, what will be the, this must be wrong, time dapat to. What will be the time if the regular Weir is one-sided contracted? So, yun. So, since this is a falling head, di ba alam natin, kapag ka-discharge, Q is equal to volume over time. Okay? Ngayon, ito yung hinahanap natin. Time. Then, ang discharge natin is, tawag dyan, discharge is variable. Kasi syempre, iba-iba yung head, pababa ng pababa yung head, pahina ng pahina yung discharge. So, discharge is not constant. Etong B, alam natin to. Check. Okay? So, since this is variable, ang gagamitin natin na discharge is average discharge. Okay? Paano natin kukunin yung average discharge? Eh di yung discharge on the average discharge is average or discharge from the start plus discharge over discharge and discharge divided by 2. Yan na yung average discharge natin. Okay? Ano yung discharge nung simula o yung HA equal to 4 meters at ano yung discharge nung tapos na yung discharge o nung tapos na yung flow. Siyempre, nung tapos na yung flow, ano yung discharge natin? 0 na. Diba? So, ganun lang kadali ang gagamitin natin dito. Okay? Pero ang una natin yung problema is, ano yung discharge yung simula? Which is gagamitin natin kapag contracted Weir, ginagamit natin is Francis formula, which is 1.84 L prime times H raised to 3/2. Okay? Since this is a regular or two-side contracted Weir, L prime is equal to L minus 0.2 H. Okay? So, L is 200 Then, head of water is 4 meters. So, ang L prime natin equals 200 minus 0.2 times 4. So, this is 199.2 meters. Okay. Then, ang kasunod ay, edi substitute mo na rito sa may Q. So, Q equals 1.84 times 199.2. Tapos, head is 4 meters raised to 3 halves. So, ito yung discharge nung simula. O nung ang head ay 4 meters pa. Oops. 1.84. 199.2 times 4 raised to 3 halves. Oops. So, discharge is 2932. 2932.224 cubic meters per second. So, the average discharge QAV is equal to, ilan yan? Divide natin 2 by 2. Kasi Q start divided by 2, ganoon lang eh. So, 1466.112. Okay? So, yan. Oops. Cubic meters per second. So, ayun lang. Pwede nating makuha yung time as volume over discharge. Di ba? Ganun lang. Tapos, volume is 1 million cubic meters. Tapos, ito na cubic meters per second. So, sagot is 682.076 seconds. Or in minutes, that is 11.34 o 11.37 minutes. Okay, kayo nang bahalang mag-check. Okay, so that's it. Itong letter B, kayo na lang bahal mag-check kasi magbabago lang naman dyan is ito, yung L prime. That's L minus 0.1 H. Okay?